Well, a very good afternoon and thanks for clicking on, or should I say good evening. It's the late edition of Vogan's European Outlook. It is Tuesday, and what we're looking at here, we're looking at the 10 HPA temperatures, the initial. So this is as of now, and we have got an official sudden stratospheric warming event taking place with the split in the polar vortex. So the initial warming was over Siberia. It started to push and push and push at the polar vortex, and eventually we've now seen that split occur with one piece over North America and actually the main piece over Eastern Europe here. So this is a 10 HPA, folks. This is in the upper portion of the stratosphere, and in today's video I want to look in greater detail as to how important it is to look at the finer details, rather than just saying we've got a sudden stratospheric warming, we're guaranteed to see cold into the mid latitudes, and more importantly, we're guaranteed to see cold over the British Isles. That is not the case, may I add. It is not as simple as that, and I'm going to show you just why it is not as simple as that. So this, like I say, is a way up at 10 HPA. So we're talking about the upper portion of the stratosphere. So at 10 HPA, we've got a sudden stratospheric warming. In fact, we've raised the temperature at this level some 53 Celsius in the space of 48 hours. So a very, very impressive, classic strat warming event taking place. So we've seen the split here. Why is it then that the modelling is indicating a warm pattern, not just for next week, but really through the remainder of January? The answer for in terms of that comes to what I'm going to show you next here. Let's have a look at a tweet that was by Mike Ventris, who is a weather expert over in the United States here. This is a look at the polar temperature here and a cross section of the polar vortex here. So what we're looking at here is that sudden stratospheric warming that has now taken place in the upper. If you look at this chart here, that is basically the depth of the atmosphere from 10 HPA right up at the very top, right down to 1000 HPA at the very bottom here. And what's important to remember, folks, is that the atmosphere between here and here is not connected. And what you need to find is you need to get the strat warming taking place, and then we get the downwelling. We get the coupling between the stratosphere and the troposphere underneath. And then once you get that, that is when the modelling is going to understand what's going on. So if what's going on up here or way up in the upper levels of the atmosphere, how is the modelling at 500 millibars, so the lowest 18,000 feet of the atmosphere, how is the modelling going to understand what's going on when it's way up above that level? So it's a very, very good question here, and that is something that we need to pay attention to, is the fact that the modelling, in a sense, is not understanding what's going on away up in the upper levels of the stratosphere here. But once you start to get that coupling, we start to reverse the winds from westerly to easterly as we go down in altitude. That is when the modelling is going to start to understand what is going on in the atmosphere. It has to have something physical to work with, to therefore project, make that calculation as to what's going to take place further down the road here. And at this very moment in time, the modelling is not seeing it, because we haven't seen the downwelling effect of the sudden stratospheric warming at 10 millibars here. So you can see here, let's go back to the chart that I just showed you. We've got the split. This is away at 10 millibars. Nice strong warming centered right over the pole, over the north of Greenland here. You're saying to yourself, wow, we've got a cold pool over North America, we've got a bigger cold pool over Europe. That is going to produce another December 2010. Not necessarily, folks, because at the moment the atmosphere is not reflecting this down at lower elevations, at lower altitudes here. So let's have a look at the very same chart. So this is the initial at 70 HPA. So this is still high in the atmosphere, but this is a lower portion. This is the lowest portion of the stratosphere, and the time frame is the exact same. So this is now at 10 HPA, and this is also now present time at 70 HPA. And you notice the big fundamental difference here is we've got blues representing colder air over and to the east of Greenland, hooking up to the north of Scandinavia. The warming is actually on the other side of the pole. So we've got warmth extending from Asia into the northwest of North America here. So that does not look anything like that, does it? We don't have any warmth over Greenland and over that. So in a sense, what we're talking about here is you're saying to yourself, why are we going to see warmer weather again? Why is the modelling not seeing any cold weather coming? This is exactly why, because we don't have the right conditions in the lower portion of the stratosphere. But as we skip on, this is 168 hours from now. You notice something here. The warming starts to progress in over the pole and towards Greenland and towards Baffin Island here. That is significant, folks. And this is all the way out to 360 hours from now here. So you can see that here now, 384 hours in fact. And so what I'm trying to tell you is remember the lag. 10 to 14 days after the initial warming takes place, it's usually, if you get the coupling between the stratosphere down into the troposphere, what that does is, where you've got the warming taking place at the lower portion of the stratosphere, that starts to affect the atmosphere underneath it. So if you start to warm the stratosphere down in low levels, what that's doing is it's causing the expansion of the stratosphere and the contraction of the troposphere. Now, of course, what separates the troposphere at the bottom with the stratosphere on top is the tropopause. What you're doing is essentially, when you're warming the stratosphere, you're then pushing the tropopause down in elevation. So you're squashing, you're contracting the troposphere and lowering the heights. And what that essentially does is it forces the rise in barometric pressure and high pressure. So what I'm trying to say is that the warming that's taking place, progression from here across the North Pole and onto the western shore of Greenland, eastern shore of Canada, is essentially where the NAO is going to go negative. That there is going to be reflected in the 500 millibar pattern. So watch this space. Essentially what I'm meaning is we're going to start to see high pressure strengthen over this region here, forcing the trough to develop over eastern North America and deepen. And also we're going to see that hopefully over the western side of Europe as January progresses. From about mid-month onwards, folks, watch this space. Watch what happens. We'll see the high pressure building in this region here. We've got twin troughs on either side of the Atlantic, and I do think that the modelling is indicating some very cold air developing over Eastern Europe. And then eventually, if we get this setup taking place, we'll start to lock the pattern in place, and you force the cold pool from Eastern Europe westwards into the UK here. So I think the period specifically between the 15th and the 20th of the month could get very, very interesting indeed in terms of winter weather. Next week, even the beginning of the following week, people are going to start to say that winter is over. We're going to start to see the air coming in from the west-southwest. We're going to see milder conditions, but that is usually a precursor of a cold spell triggered by a sudden stratospheric warming event here. So it's going to be very interesting to see exactly how the downwelling and the coupling unfolds here. Strat warmings don't always favour cold in the British Isles here, but when you've got this setup where you've got a west-based negative North Atlantic oscillation that tends to allow the cold air to get pulled further west over Europe. If you have a more east-based negative NAO, you sometimes have that ridge a little bit too close to the UK. We've seen that in 2011, 2012, and of course, bitterly cold air over Europe, and literally the ridge stopped the cold air from crossing the North Sea from the Netherlands into the UK. When in fact, we've seen the coldest temperatures in southeastern England. Holbeach, I believe, that winter in 2012 reached -15, but it never really got across the North Sea properly here. So a lot of it depends on exactly where that ridge develops, where the cold air is distributed to. But certainly a big test coming up here. Keep it right here on YouTube, on markvoganweather.com, on Twitter, and I'll keep you up to date as best I can. But exciting times to come, I would say. Hope you have a great evening. Bye for now.